Welcome to a sim code. How about we make coding a little more exciting? If you subscribe to my channel, I'll make sure every tutorial is as fun as it is educational. Ready to level up together? In text classification, the goal is to assign predefined labels, such as positive or negative, to text data based on its content. To do this with scikit-learn, we typically start by importing the necessary libraries, such as count vectorizer for converting text into numerical data, word counts, and multinomial NB, a naive Bayes classifier suitable for text-based tasks. The process begins by splitting the data into training and testing sets using train_test_split, ensuring the model is tested on unseen data. Then, the text data is transformed into a feature matrix using count vectorizer, which converts each word into a feature based on its frequency in the text. After that, we train the classifier with the training data using fit function, and evaluate the model by predicting the labels of the test data and comparing them to the true labels with accuracy and other metrics. This workflow allows us to build and evaluate a model that can classify new, unseen text into the correct categories. First, we import the necessary libraries and modules. A package for handling arrays and numerical operations, but not heavily used here. Function for splitting data into training and testing sets. Class for converting text data into numerical feature vectors. Naive Bayes classifier, commonly used for text classification. Provides functions to evaluate the performance of a model. Let's assume we have some text data, a list of sentences, and their corresponding labels. Each sentence is a string, and the label is a string indicating whether the sentiment of the text is positive or negative. Positive sentiment. Positive sentiment. Negative sentiment. Positive sentiment. Positive sentiment. positive sentiment. Labels is a list of strings where each string corresponds to a sentiment label of the text in the text list. Now, we split the dataset into training and testing sets. Train_test_split is a built-in function from scikit-learn that splits data into two parts: training data and testing data. Test_size equals 0.25 means 25% of the data will be used for testing, and the rest for training. Random_state equals 42 ensures the split is reproducible across different runs. The return values are x_train, training texts, x_test, testing texts, y_train, training labels, y_test, testing labels. Next, we need to convert the text data into a numeric format that the machine learning algorithm can understand. Count vectorizer is a class that transforms a collection of text documents into a matrix of token counts. In simpler terms, it converts each word in the text into a feature by counting its frequency across all texts. The fit_transform method does two things. 1. It fits the vectorizer to the training data by learning the vocabulary of the training texts. 2. It then transforms the training text into a matrix of word counts. X_train_vectorized is a sparse matrix where each row corresponds to a document, text, and each column represents a word. The value in each cell indicates how many times that word appears in the corresponding document. The transform method only transforms the test data, x_test, using the same learned vocabulary from the training data. This ensures that the model sees only words it was trained on and prevents data leakage. Now, we choose a classification algorithm. Here, we use the naive Bayes classifier, which is suitable for text classification. Specifically, we are using multinomial NB, which is a version of naive Bayes designed for discrete features like word counts. Naive Bayes is based on Bayes' theorem and assumes that the features, words, are conditionally independent. Multinomial NB is ideal for problems where we deal with word frequencies or counts, like in text classification. The fit method is used to train the classifier on the training data, x_train vectorized, and the corresponding labels, y_train. This method calculates the probabilities and other parameters that the classifier will use to make predictions. Now we have a trained classifier, and we can use it to make predictions on the test data. The predict method returns the predicted labels for the input data, x_test vectorized. The predicted labels are stored in the variable y_pred. To evaluate the performance of our model, we use metrics like accuracy, precision, recall, and F1 score. Accuracy_score calculates the proportion of correct predictions compared to the true labels. Accuracy is a built-in function from metrics. To provide more detailed performance evaluation, we can also compute a classification report. The classification_report function gives us a summary of precision, recall, and F1 score for each class, positive and negative. Another built-in function from metrics. Finally, we print the results. Now run our code. I hope you had a blast. Don't forget to like and hit the subscribe button.